So during the process of breathing in and breathing out, diaphragm and external intercostals relax, and during the labored breathing, this is the normal breathing, so diaphragm and external intercostals, both of them are relaxing when we are expiring. And in the other case, diaphragm and external intercostals contract when we are breathing in. At that time, so when you inhale, you actually can feel it. When you inhale, it seems like your abdominal area is rising. Your whole area, abdominal area, rises a little bit, and that is because this diaphragm becomes flattened when you inhale. So the upper part of our body, which is thorax, its capacity increases. When you inhale and diaphragm rises, its normal position is this position here. Because of inhalation, it becomes flatter. And when it becomes flatter, it creates a little bit more space here. So this dome-shaped structure, which is when it is relaxed, and when it contracts, it becomes flattened, and it opens, and it increases over thorax cavity a little bit more. That's how we can breathe in, because otherwise, if we don't raise, if the cavity does not expand, then more capacity of air is not present in this area. When you exhale at that time, so after inhaling, when you relax, when you exhale at that time, the diaphragm relaxes, so which is shown here, and it becomes that dome-shaped structure also. And the dome-shaped structure from a flatter surface actually extends into our thoracic cavity. So when it extends into the thoracic cavity, it decreases the area, it decreases the capacity in our thoracic cavity, and that's why we actually exhale. So it is the inhalation and exhalation is the function of our diaphragm. So when it expands at that time, it becomes a little bit dome-shaped structure. So the capacity in our thoracic cavity decreases. That's why we expire. That's why we exhale. So when it becomes contracted, it becomes flatter, and that flatness of the diaphragm creates more area in the thorax cavity. So when the area expands, then it brings in more air to fill that void that is created by expansion of this cavity here. This happens when things are normal, when you're breathing normally. If you are breathing, if during the kind of a labored breathing, during exercise or because of the emotions at that time, all inspiratory muscles are active at that time. So intercostals and many other types of abdominal muscles are also active at that time as well. So these muscles as well as these muscles. So these muscles are considered as the muscles of inspiration. These sternocleidomastoid that we talked about, scalenes and pectoral minor, external intercostals, all of those are active at that time, and which are considered as the muscles of inspiration. But majority of the time, the 2-3 muscles that we can actually name easily are these intercostals, diaphragm of course is there, intercostals, and external intercostals. So this is just to show you how they look like. The first layer, which is a more superficial layer, is the external intercostals, and deep to that is internal intercostals, and there are actually another kind of innermost intercostals as well that we did not talk about. So, as you have, those of you who have taken physics,
No.
Okay, so that rules out one student. So, there is actually a direct correlation between the volume and pressure. The relationship is it's an inverse relationship. As you increase the pressure, the volume decreases, and as you decrease the volume, pressure increases. So for example, if you take a balloon, if you take a balloon and you press it, when you press it, what are you trying to do? You are creating, actually, you are decreasing its volume. You are decreasing its area in which it is contained. And as you actually compress it more and more, it will explode at some point, right? So the reason for that is because the pressure inside that balloon increases to the point where the balloon, the material, the rubber of the balloon is not able to withstand it anymore. So when you increase the pressure, that's what happens inside. If you take a balloon and leave it actually in a place where it becomes hotter and hotter, what will happen? It will expand to the point where it will explode also. So what is happening in those situations is when the volume is being decreased by squeezing something, a balloon is being squeezed, then the pressure is building inside. And that pressure helps it to, and after some period of time, the volume is not able to contain it, and it will just burst from there. The same thing is actually in play in our lungs. This is what is happening also. When we inhale like that, we inhale, and that inhalation is because of the diaphragm. When the diaphragm becomes flattened, then the cavity, which is our thoracic cavity, expands. The pressure, which is because of the air present in our lungs, decreases. When the volume increases, then the pressure decreases. So because they are inversely related to each other, when one increases, the other decreases. So when we inhale, the pressure which is in our thoracic cavity decreases, and that's how we can inhale. That is the only reason actually we can inhale, because we increase the capacity of our thoracic cavity. And when we exhale, the reverse process takes place. We decrease the capacity of our thoracic cavity. That increases the pressure in our thorax. So when you increase the pressure, the volume decreases. So it does not increase. The direct correlation will be, if pressure is increased, volume increases. If volume is increased, pressure increases. That is a direct correlation. But in case of our lungs and our thoracic cavity, the relationship is a reverse relationship. When one increases, the other decreases, and when one decreases, the other increases. So the change in the volume results in the changes of the pressure. When thoracic cavity volume increases, pressure decreases. When the thoracic cavity volume decreases, the pressure increases. So that is the kind of basis of the flow of air in our lungs. So, and as we also know that air pressure always goes from higher pressure towards lower pressure. So when you take those tanks of helium for the parties, at that time that tank of the helium is under a lot of pressure. So that's why when you open the valve, or when you let some kids do that, they will empty that in a few minutes. When you open that valve, the balloon gets filled because there is high pressure inside the tank. And there's no pressure of gas inside the empty balloon, so it gets filled like that. Our breathing is also related to the same mechanism. The pressure of the air is higher on the outside, and pressure of the air is lower inside our lungs, so air goes inside the lung. And when we exhale, at that time, the pressure of our thoracic cavity increases, and it is higher than the outside. So that's how we exhale. And this is all kind of maintained with the help of our muscles. It is helped, and it is actually just simple physics being applied. It does not really involve our muscles also. Muscles are changing the cavity, the space of the cavity. Otherwise, it is just physics that is playing its role, which is based on volume and pressure. So when we inspire, at that time diaphragm descends, and descending means the diaphragm, which is like this, becomes flattened like that, becomes somewhat flattened. It's not exactly like that, it becomes somewhat like this. So the flattening of the diaphragm expands over thoracic cavity. the volume in that area increases, so that decreases the pressure. So when the pressure decreases inside, because the diaphragm descends, at that time, the capacity increases, the pressure decreases, and if the pressure is lower inside and it is higher on the outside, what will happen? It will be, the air will go inside, because the pressure is higher on the outside through our nasal cavity. So because the pressure is lower inside, so from higher to lower pressure, the air will go inside our lungs. And atmospheric pressure is greater than the alveolar pressure. So atmospheric, which is the air pressure, is higher than the alveolar pressure. Alveolar pressure is inside our alveoli. This is inside the lungs. So there are three types of pressure that we'll see. One is the atmospheric pressure, which is on the outside, and then the other pressure is the alveolar pressure, which is the pressure of the air inside the alveoli, and the third pressure is the pressure in our lungs, in our thoracic cavity, which is called pleural pressure. So atmospheric, alveolar, and pleural are the three types of pressures that are used to describe the respiration. So atmospheric is, most of the time higher. And what type of gases are present in the air? Why is the pressure of the air? What type of gases do we see in the air? What is most of the air made of? Oxygen, carbon dioxide gas?
CO2 and nitrogen.
No.
It's nitrogen. Nitrogen is about 80%. So it's all inert, nitrogen. So this is about the, those mechanics are trying to fill your tires with nitrogen. They say it's better for your tires. Give us some money and we'll give you that nitrogen. What they're doing is actually they're getting from the air. They used to give you air, now they're giving you more nitrogen. So what else is there?
That'd be oxygen. 20%, isn't it?
But 21% is oxygen.
Yeah.
So, and then there are small portions of other things which are carbon dioxide gas is actually much lower than that. Where is that ratio? Pardon?
PCO2? What is it?
PCO2 is the partial pressure of carbon dioxide gas.
So that is part of it, isn't it?
Yes, that's part of this. So actually oxygen is about 20%, and let's see.
Isn't there argon in the air too?
Very small traces.
Very small traces, right?
Yes, carbon dioxide gas is there. There are several other gases too, but their ratio is so small that they are not even considered. There are some water vapors also. It's also made of some water in there too. Let's see.
Hey, doctor.
Yes, sir.
How low does the percentage have to be for oxygen for us to survive with another element in the air?
It can drop to from about 18-19% to it can drop to about 10 to 12%. Then we can still survive because of the capacity of the hemoglobin to carry it and maintain it in that way.
That's given that you have to mix as nitrogen, not something like hydrogen.
Oh, yeah. Well, I know argon is argon.
Yeah, that's right. So it's about 79% of nitrogen, 21% of oxygen, and then there are traces of carbon dioxide gas and other gases in it. So, carbon dioxide gas is still okay. What is really more dangerous is this gas. So the people who actually close their say offices or bedrooms, and they turn on some heaters like that use gas, natural gas.
Talking about carbon monoxide.
Yes, carbon monoxide. So carbon monoxide, or sometimes actually people, what they do is actually they close the doors of their garage during winter time, and their cars are running. So a lot of time actually people die because of that, because it produces carbon monoxide, and carbon monoxide has much more affinity to be carried in the blood than oxygen. Carbon dioxide has less affinity. Carbon monoxide has actually very high affinity for hemoglobin, so that's why people actually die much faster with carbon monoxide.
Does helium have the same properties as well?
No, helium is a very inert gas. It does not really react. So that's why it's used in balloons. And hydrogen is very reactive, so that's why actually hydrogen is never used, because if you try to use it, it will explode. So carbon monoxide is dangerous. People actually use it to commit suicide also, by using the same method I just described, so I'm not going to actually repeat that. But people do use it for that purpose. All right, so it's time to break. Let's take a break now.
Thank you.
And